Hello everyone, welcome back. Today we will be covering our network address translation NAT, which we will be discussing about how our how our NAT changes from one particular IP address to another particular IP address, usually translating from a private local IP to a public internet IP. It is one of the most fundamental and important concept in netting because previously, in history, uh, we used only a 32-bit binary number, which if you do 2 to the power 32, then it comes around 4.3 something billion. So that much only IP address that we were allowed to use in a whole world. So I mean that's not sufficient in today's time. It's not practically possible. So there are billions of devices. So in order to fulfill all the IP address, we use NAT, which is a very important concept. So let's move. Before moving to our NAT, let's see what type of IP address we basically use. So first is private IP. So these are internal use only inside your local area LAN, right? They are completely free to use, but they are not routable and the public internet. So basically the IP address that you use, that device assigned itself, assigned by a router, which is of our particular devices. We will be discussing more while we move further. Okay, another is public IP. So this is unique globally registered address assigned to your router by your IPS, which is internet provider. The whole world can see this address. So basically there are two kinds of IPs, right? Private IP and public IP. So introduction. So what is NATing, right? So every single device connected to the internet needs a unique ID, right? Like I said already, back when IPv4 was designed, it was only allowed for about 4.3 billion addresses, because they only used 32-bit binary. So if you do 2 to the power 32, 4.3 something billion will come. So the creators thought that there will be plenty, but the smartphone, laptops and smart TVs and IoT devices ran out of IPv addresses years ago, right? So how is the internet still working? The address is NAT. Obviously the answer is NAT, which is network address translation. NAT is the ultimate savior of IPv4. It allows the entire home or office network, dozen of devices, to share one single public IP address to communicate with the rest of the world. So this, I'll give you a brief example. Okay, so assume this is your PC. Okay, this is your laptop, this is your iPad, just for example, and this is your phone. This is all the devices that is used in your house home. Okay, and this is switch. Okay, basically switch work is to forward the traffic. Okay, this is our router and this is our internet. Okay, so as you can see, each every device has an unique IP addresses, obviously. So these are private IP. These are each unique, which are assigned to a specific devices, right? A particular devices. So these are the private IP, but respectively. And this is a router which is used in your home. Say this is a router which is connected to your IPS, and this is how your internet is being used, LAN server, which is basically this is your public IP, and whatever you search, and this will be your public IP, and whatever you search will forward to the internet, and similarly forward back to you as a resources. So assume you are searching from your laptop google.com, then this is a particular IP, right? Private IP. But the public IP now public IP will now go to the internet and search and give you the result of google.com. Similarly, if you try to visit instagram.com, right, the router will search to the internet using this public IP. It won't use your private IP. By doing this, the overload of 4.3 billion which we had issue, right, is solved. So every devices in your, doesn't matter if you have 50 device in your home, the public IP will handle all the searching, all the things that you search in the internet. So basically this is how NAT works. Okay, Now, three main types of NAT that we need to focus is static NAT. So, by the name, it maps a single private IP address to a single public IP address permanently. It is basically used in hosting servers. If you have internet web server and people outside needs to access directly, you need to dedicate public mapping. So basically, static NAT one-to-one. So another is dynamic NAT. So in dynamic NAT, the router holds a pool of public IP address. Right, it holds a pool of public IP address. When an internal device wants to talk to internet, the router dynamically assigns an available public IP for the pool. Once the device is done, the IP gets the IP goes back into the pool. So basically, it has a pool of public IP addresses. When an internal device wants to talk to the internet, right, then the router dynamically assigns it to the available public IP for from the pool to a device. So it's basically it is done that. Our last type is NAT overload or PAT, port address translation. This is what happens in 99% of home router. So right, it maps multiple private IP address to one single public IP address by tracking port address. So basically, this picture, this is the example of PAT. Okay. So these are the three. Okay, sorry, my bad. Yeah. Okay, so example of our NAT. So this is gonna be a bit detailed. Okay, so first assume this is our laptop, right? This 192.168.1.5 is our private IP. This is our private IP for our laptop. Okay, assume this, and we want to visit our website, which is google.com. Our destination IP is 142.250.190.46. This is an IP address of a Google. So in order to fetch resources from the Google, we need to visit this IP address and request the resource, right? So, and always know that this is a source port. So source port is very important. So this is our source port. Okay, so what happens is we'll send the data packet. Once we send the data packet, we'll have a router, right? So what happens is our router will have our NAT translation table. Okay, so now our router will have NAT translation table. This is just a vague, but it will be in detail. So it will have a source port, right, assign port, destination port, source IP, destination IP, everything, each and everything. So our destination IP, so our source port is source IP, our source IP is so here the public obviously router will use our public IP. So our public IP is 203.0.113.1. It will replace this private IP with our public source IP. So once it does that, it will assign a port. Now assign port is 5001 in our router, right? So it will have an assign port, public source IP, and destination IP of 142.125.190.46. Here in our this router transformation, it just switches the private IP with our public IP, nothing much. So once it does that, it goes to internet, it fetches all the, and it goes to Google, it fetches information, right? And this is our public router IP. So basically source is our obvious destination, right? It changes. Port is 5001, destination is 203, which is our public IP, right? And it goes, this router and this router is same, please do not get confused. And once our Google fetches, it gives the resources back. So it gives the resources back. So what happens is we have a NAT table, right? NAT table, and we know with the help of our this assign 5001, it knows this the destination IP is 203.0.113.1. and again, with similar to our NAT translation table, we know that this 103.g031 is our public IP, and this public IP private IP is 192.168.1.5. So basically it knows this. Once it looks at the assign port 5001, it knows that resource is this router knows that it has to send back to our 192.168.1. so this basically how it works. This is a detailed example of how NAT basically works. Okay, so this is just the theory of how it works, right? So nothing much. So whatever I told you, that is how basically it works. So this is how NATing works. This is a very fundamental and, like I said, very important concept. So thank you for being at the end of the video. Thank you for listening. I'll see you in the next video. Thank you guys.